Here we are given a circle with its center at the point O, a tangent QA of length 7.2 centimeters, and point of contact with the circle is this point Q here. Another tangent PC of length 5 centimeter, and its point of contact here is at the point P. Now, what is a very important information that is given? These two tangents are parallel to one another. Now, what does that mean? That means that the center will lie on the line joining these 2 points of contact. Center will lie on the line joining P and Q. Or in other words, what you have here is a straight line, or in other words, 180 degrees is what you see here. What else is given? If you look at this line, suppose I name this point B. What do you see here? AB, even when extended, touches the circle only at one point. What do we call such lines? We call them tangents. So what you have here is a tangent. Now what we have to find is exactly this. We need to find what BO, or in other words, what the radius of this circle is. Now the first step that we are going to do is we are going to prove that this angle here and this angle here are equal to one another. How are we going to prove that? Take this triangle as 1 and this triangle as 2. Why will these two triangles be congruent? If you see, AQ and AB are tangents from the same external point A, which means they are equal in length. OQ and OB are the radii equal to each other, and OA is the common side. So by SSS criterion, these two triangles are congruent to one another, which means by CPCT, these two angles are equal to one another. Now repeat the same story here. Here also we are going to prove that this angle here and this angle here are equal to one another. How are we going to do that? The same thing. Now I will take this as 1 and this as 2. The same story. CP and CB, tangents from the same point, same external point, so they are equal to one another. OP, OB, radii equal to one another. OC is the common side. Again, by CPCT, these two angles that you see here are equal to one another. So let these two angles be equal to A and these two angles be equal to B. So what do you see here? A plus A, which is 2A, B plus B, which is 2B. So all of these added, what did we say in the beginning? It is 180 degrees. What you have is a straight line, or in other words, you have A plus B is 90 degrees. So you see where we are going with this? This A plus B, this angle here is 90 degrees. Now let us forget about everything and then concentrate just on CAO. What do we know about AB? Both AB and AQ are tangents to the circle from the same point A, which means what? AB is 7.2 centimeters. Similarly, what is CB? CB here will be 5 centimeters. Then what else do you have? We just proved that here what you have is a right angle. And what else do we know? What you have here is again a right angle. OB. Why is that? Because at the point of contact, the tangent and the radius are perpendicular to one another. That means you have a right angle here. Then what sort of a situation do we have here? What does the geometric mean theorem say? Now I will use the same alphabet so that you don't get confused. If you have a right triangle here, right angled here, and you have an altitude, you have a perpendicular here, say P. I'm using the same alphabets. Then suppose this length is x, this length is y, and this length is z. Then we have that x square is equal to y into z. Bring the same situation here. You see a right angle here. You see the hypotenuse, and to the hypotenuse you see this perpendicular line that you see here. Then this perpendicular line, its square is equal to the product of these two sides. Or in other words, this is r, right? This is the radius, which means its square is equal to 7.2 into 5, which is what? 36, right? So r is equal to 6 centimeters. Now this can be proved in many other ways, but that is all very time consuming. Geometric mean theorem as it is not included in the portion. This year 2025 it is not included as it is in the portion.